Objects like supernova explosions, neutron star collisions, and the formation of black holes all play a role in the generation of gamma rays. This then represents the outer limits of our astronomical and physical knowledge. In March of 2018, astronomers witnessed the dim light in the sky suddenly come on for almost a minute before slowly going out again. For all the interested sky watchers out there, this is a delight, but it's also a reminder that our tiny planet is in the crosshairs of a very powerful cosmic weapon. Experts believe this weapon was responsible for wiping out all life on Earth about the year 44 million years ago. In October of 2022, one of these cosmic power sources once again brought home the fragility of existence. Could past events happen again in this infinite universe? Is it this cosmic superweapon's fault that we're always by ourselves in the universe? Does gamma radiation really pack that much of a punch? Finally, does Earth have what it takes to survive the possible destruction brought on by this heavenly superweapon? The purpose of today's lesson is to begin answering these concerns. We should get started right away. As any fan of science fiction knows, heroes and villains with gamma powers are not to be trifled with. Gamma ray bursts, by a strange twist of fate, are the most powerful explosions in the cosmos. An extremely massive star, one with a mass many times that of the Sun, can collapse into a black hole in a fraction of a second. After shedding its outer layers, the star sends forth two beams of light so intense that they can be seen from billions of light years away. During these brief gamma ray bursts, more energy is released than the Sun could produce in a billion years. Gamma rays, an unexpected finding, were discovered by chance. That finding, however, sparked an international hunt that has spanned decades and continues to this day, involving hundreds of astronomers from every continent and nearly every observatory on Earth. But in the early hours of Sunday, October 9, 2022, astronomers all across the world were taken aback by the passing of an extraordinarily bright and long-lasting pulse of tremendous energy that swept over the planet. According to scientists, the gamma-ray burst identified on Sunday was the most powerful ever seen, releasing nearly 18 teravolts of energy in a brief burst, enough to power the United States for an entire year. In 2021, scientists initially assumed the gamma-ray burst emanated from a nearby source, but later determined that the actual distance to the source was closer to 2.4 billion light-years. However, even though both gamma-ray bursts were relatively far from Earth, a closer one might have had disastrous effects on our planet. Specifically, gamma-ray bursts have been hypothesized as the cause of the 440 million-year mass extinction. Do gamma-ray bursts account for the fact that we haven't found intelligent life anywhere else in the universe? In the 1950s, scientists like Enrico Fermi wondered aloud over lunch, where is everybody? There must be some other sentient society out there with the technology to travel between the stars. Given the sheer quantity of stars in the universe, if that's the case, then how come no alien ships have come nearer to our large blue planet? To what extent do we find ourselves completely alone in the cosmos? There was no evidence for such civilizations in Fermi's day, and there is none now. The Fermi paradox is based on the idea that an advanced civilization a million years ahead of our own should have left signs of its existence in the sky by now. It is possible that the chemical makeup of a planet's atmosphere is altered when the powerful gamma-ray beam accidentally reaches an unlucky habitable planet, depleting whatever layer is built up to defend against dangerous cosmic radiation. This would mean that the planet would be subjected to even more cosmic waves, killing off even the most radiation-resistant creatures that would otherwise contribute to its flourishing. For hypothetical sentient life forms like ourselves, this is not good news. The arrival of sentient life on Earth was likely slowed or even prevented due to the frequency with which this event occurred, or because it occurred at a crucial moment in the planet's evolutionary history. The frequency of these death rates needs to be discussed in relation to a potential timeline of intelligence progression when contemplating the existence of extraterrestrial civilizations. Even cosmologist James Ennis considered this possibility. He proposed the astrophysical idea of a transitional phase between the absence of intelligent life in the galaxy and the expected dense population of intelligent life. According to his research, the Milky Way galaxy is at a critical juncture where new forms of life can emerge and thrive. The notion is that we are entering an era in which the frequency of gamma-ray bursts is low enough to allow life to grow more freely, in contrast to earlier epochs in which the frequency was higher and potential intelligent species would have been inhibited from emerging owing to the radiation onslaught. Thus, the gradual decrease in gamma-ray burst activity may be a mechanism that promotes the survival of living things, giving life a chance to voice out. This also modifies the premises of Fermi's paradox, which gives us a far longer duration, in the billions and billions of years, for life to spread and interact with each other. The paradox assumes that there exists another intelligent life form out there that may have made contact with us. In reality, they could be able to or just have started exploring space, or as Anna speculates, there might be no intelligent life on the planet. Thankfully for us Earthlings, none of the detected bursts have come from anywhere near our Milky Way galaxy. What if, though, a gamma-ray burst suddenly appeared in the area as a highly developed species? What would happen to us? Could we do anything about it, even if we wanted to? Gamma rays are extremely harmful because they are extremely powerful bursts of energy. There is a huge difference in intensity between one gamma-ray photon and 1,000,000 regular photons. Now imagine that this cosmic superweapon was aimed squarely at Earth. Damage to Earth from a nearby gamma-ray burst would be comparable to that caused by an asteroid strike. For starters, it would instantly wipe out our atmosphere, leaving us vulnerable to dangerously high amounts of UV radiation from the sun, as there would be no protective ozone layer to shield us. Sunburn and skin cancer rates would reach unprecedented heights. Herbivores that primarily feed on plants would perish along with all plant life, and the unidirectional flow of energy would be disrupted. After the death of the majority of plants, the oxygen level in the atmosphere would drop dramatically, leading to the deaths of many creatures, including carnivores and omnivores. There's just so much that can be done to prolong human life, even with as many oxygen masks as feasible. If our satellites could detect the gamma rays hurtling towards Earth at nearly the speed of light, it wouldn't alter much. The good news is that our ozone layer can regenerate naturally, but this will take an absurdly long period. As a result, the sun would have been able to thoroughly scorch our house before we fled, leaving us entirely exposed. Do you think we're going to perish soon? Also, what can we do to help Earth in a galaxy like ours? We may encounter a gamma-ray burst once every 1,000 years, and even then, it would be too far away to cause any damage. But there is something we can do to improve our dwelling. There are more pressing dangers to life on Earth than trying to come up with 1,000,000 techniques to deflect the gamma-ray. The loss of habitat, for example, could cause a number of animal and plant species to go extinct. We could also use reusable shopping bags and water bottles instead of throwing them away after one use. As the old adage goes, you must choose to take hold of what you can control and let go of what you can't. There are countless potential threats to the survival of humanity, but all we can do is focus on what we can influence. While gamma-ray bursts are among the most powerful phenomena in the universe, their occurrence is relatively rare. Despite their intensity, their impact on Earth is not something we typically need to worry about. As of now, gamma-ray bursts are not frequent enough to pose an immediate threat. Still, understanding them provides crucial insights into the underlying mechanics of the universe and our place within it. The rarity of gamma-ray bursts actually contributes to our survival, offering a brief but vital reprieve from potential extinction events that could otherwise reshape life on Earth. Scientists have long studied the effects of cosmic radiation and the environment in which these massive explosions occur. These bursts come from stars much larger than our Sun, collapsing under their own gravitational force. The result is an implosion that transforms the star into a black hole, triggering a powerful energy release. This energy radiates outward as two narrow beams of gamma radiation, each one directed along the star's rotational axis. The incredible intensity of these gamma-ray bursts is what makes them so dangerous. If one were to strike Earth directly, the consequences would be catastrophic, even if the burst was just a fraction as powerful as the most extreme examples observed. However, even with their incredible energy, gamma-ray bursts do not typically affect planets outside their immediate vicinity. In fact, even the closest detected gamma-ray burst, one that occurred 2.4 billion light-years away from Earth, was not powerful enough to harm our planet. This distance, while far in terms of our daily lives, is still a relatively small portion of the vast scale of the cosmos. The immense size of the universe means that gamma-ray bursts, while energetic, tend to target regions of space far from Earth, leaving us largely unaffected. Nevertheless, Gamma-ray bursts are far from the only cosmic phenomena that have the potential to shape life on Earth. The universe is home to a variety of dangers, ranging from supernovae to asteroid impacts, each one capable of triggering significant changes in the Earth's environment. For instance, supernovae, the explosive deaths of massive stars, release vast amounts of radiation and can also create cosmic rays that affect planetary atmospheres. In the case of a nearby supernova, the resulting radiation could strip away Earth's atmosphere, much like a gamma-ray burst, leading to the extinction of life forms that depend on it. Fortunately, these supernovae are even less frequent than gamma-ray bursts, making their impact on Earth even less likely. Another cosmic phenomenon that poses a significant threat is the potential collision between stars or stellar remnants. Neutron stars, the dense remnants of collapsed stars, are capable of producing immense gravitational waves when they collide. These gravitational waves can send ripples through space-time, creating disturbances that may be detectable by sensitive instruments here on Earth. Though these waves would likely not cause direct harm, their effects on planetary systems could be profound, particularly if such an event occurred within our galaxy. A collision between neutron stars can also lead to the formation of black holes, which are notorious for their ability to warp spacetime and trap everything within their event horizon, including light. Despite these threats, Earth remains an incredibly resilient planet. It has withstood countless cosmic events, including asteroid impacts and episodes of extreme volcanic activity, that have shaped the planet's environment. The fact that Earth is still able to support life after billions of years of such events speaks to the planet's unique combination of factors: its distance from the Sun, its magnetic field, its atmosphere, and its active geological processes, all of which contribute to a stable and habitable environment. One key factor in Earth's ability to resist cosmic threats is its atmosphere. Our planet's atmosphere serves as a shield, protecting us from harmful radiation, solar wind, and other high-energy particles that could otherwise strip away life-supporting elements. Without this protective shield, Earth would likely be a barren, uninhabitable world, unable to support life as we know it. Scientists continue to study the various factors that contribute to the formation and maintenance of planetary atmospheres, searching for ways to understand how life-supporting conditions might arise on other planets. Astrobiologists have long speculated about the possibility of extraterrestrial life, and their research often focuses on the search for planets with conditions similar to those on Earth. The discovery of exoplanets, planets that orbit stars beyond our solar system, has expanded our understanding of the universe, offering the tantalizing possibility that life may exist elsewhere. So far, astronomers have discovered thousands of exoplanets, some of which lie in the habitable zone of their stars, where liquid water might exist. This has led to a new focus on the search for signs of life, such as biosignatures or the chemical markers of life, in the atmospheres of distant exoplanets. However, the existence of extraterrestrial life remains elusive. Despite the vast number of planets in the universe, no definitive evidence of intelligent civilizations has been found. The Fermi paradox, named after physicist Enrico Fermi, continues to be a subject of debate. It suggests that, given the vast number of stars and planets in the universe, there should be a high likelihood of intelligent life elsewhere. Yet, despite decades of searching, we have yet to detect any signs of such civilizations. The question remains: if intelligent life is out there, why haven't we found it? The absence of detectable intelligent civilizations could be due to the effects of gamma-ray bursts and other cosmic events, which may prevent the development of complex life. As mentioned earlier, these bursts could sterilize planets, preventing life from evolving or progressing to the point where civilizations could emerge. The possibility that gamma-ray bursts and similar events are a common occurrence in the universe might explain why we have not encountered any alien civilizations, despite the seemingly favorable conditions for life elsewhere. In light of these considerations, it's essential to remember that Earth's continued survival depends not only on avoiding cosmic threats like gamma-ray bursts, but also on addressing more immediate, human-made dangers. Climate change, habitat destruction, and pollution are among the greatest threats to life on Earth. By focusing on sustainable practices, conserving natural habitats, and developing technologies to reduce our impact on the environment, we can ensure that Earth remains a habitable planet for future generations. Ultimately, The key to survival lies in our ability to adapt, evolve, and mitigate the risks that we face. While we cannot control cosmic events, we can control how we respond to the challenges posed by our own planet. By investing in research, embracing innovation, and making informed choices, we can help ensure that life on Earth continues to thrive, no matter what the cosmos throws our way.